actually all have brown fat. So babies are actually born with the most brown fat, and that's why they're super cute. They're so chubby, right? They have like so many rolls, they're cute. And the reason why they actually are born with so much brown fat is because babies, I don't know if you know this, can't shiver. Like they just have to somehow stay warm. So they just are covered with brown fat. But as you age, you actually kind of lose a lot of the brown fat, but you still have a certain number that remains in your body throughout your lifetime, okay? So typically where you find your brown fat is gonna be like in your neck, your shoulder blades, around your kidneys, some vital organs, and along your spine, which in my opinion is just because of the way your body wants to protect the most important parts of your body, like your spine and your organs, you know? So there's these cells that are more like brown fat cells that are still there. And they're actually much firmer. So they're not as, you know how I said white fat is kind of like loose, you know, kind of like, it kind of hangs a little bit. Brown fat, you can't really see it because it's kind of like more hidden, but if you did have any, it's very, very firm. It's a very firm kind of fat, okay? Now, it is actually different structurally. It is in the brown fat cells. So a white fat cell there's a nucleus, right? And then there's a big fat lipid. In a brown fat cell, it is filled with a lot of mitochondria, okay? So mitochondria, as you guys may remember from your biology class, is your energy center where it produces energy. So the mitochondria in a brown fat cell isn't just one. There's a lot of mitochondria, so it's filled with mitochondria. It's actually why it's brown, because it's filled with a lot of iron. And so it's metabolically active. Brown fat is metabolically active. And it actually uses a protein, it's called UCP1. It uses a protein. The mitochondria uses this type of protein to really stimulate and produce heat and energy, right? Angela, ATP from the mitochondria, exactly. So it's filled with multiple mitochondria, whereas a fat cell doesn't have a lot of mitochondria. It may have one because it's a cell, but it doesn't have multiple, right? And it has a big fat lipid within the white fat cell, whereas a brown fat cell has multiple mitochondria in it, right? So it's very active, and it can produce a lot of energy, a lot of heat. When they study the structure of a brown fat cell, there's more capillaries, so it means it uses way more oxygen, and it has a lot of myelinated nerves. So myelination of your nerves is that white sheath that surrounds your nerves. When it's unmyelinated, it means it can handle a high level of stress, which probably shows you that with this type of cellular structure, this type of brown fat is meant to function under a big stressful situation, or when it's really cold, it needs to suddenly I almost think of the cell wanting to shake. It may not really actually shake, but who knows? Actually producing the heat and the energy to keep you warm, right? So it actually takes glucose. It actually functions differently. It takes glucose and it turns food into heat. Now, one thing I want to, I've mentioned this before, I use the word thermogenesis a lot, especially when I talk about when you eat food. You want to teach your body how to eat food and use the thermogenesis of food as an extra. I think it gives about 15% kind of boost to the calories you use up, right, in your body. So as kind of why I say I don't like it when people use too much shakes and they don't actually eat food and so all of this. So I refer to thermogenesis as the body needs to break down food, right? And so brown fat cells are a primary helper in turning food into heat, in activating thermogenesis in your body. So does anybody know why we need brown fat cells? Do you guys know why we need brown fat cells in our body? And as you guys maybe make a guess on it, so it is when it is activated, is when the temperature is particularly low. right? So it's a survival mechanism to help you when temperature starts to drop, your body needs to maintain winter gatherer seasons. Yeah, Angela. Yeah, you basically got it. When there's cold. Yeah, exactly. So when it's cold, your body is always trying to maintain homeostasis, right? So if it starts to drop, right, your body has to find some way to produce heat. And one of the first lines of producing heat is immediately getting those brown fat cells to like start to use the mitochondria, activate it, produce heat so it can maintain the body temperature. It is actually activated before you hit the shivering level. When you hit the shivering level, like it's already trying to activate other things in your body and your muscles and things to start to get more heat out of it. But it's the point before it hits the shivering level. You may not even know your brown fat cells are really being activated. It might just feel like it's a little bit chilly, but you're not shivering yet, right? That's usually when the brown fat cells are actually starting to be activated, right? So hi, Ruby, good to see you. So we know that it structurally looks different. It has a different function. White fat cells tend to store. Brown fat cells tend to be used for producing heat and extra energy when you need it, right? So then the question remains on, can you turn white fat cells to brown fat cells? So before I go into it, how many of you, just as a guess, think you can turn white fat cells to brown fat cells? Say yes, or maybe, yeah, I love to hear your feedback below, or no. So let's talk about this a little bit. So it's kind of like in the middle a little bit. So what they found is they did find that there was actually something called beige fat cells. So beige fat cells was a cross between a white fat cell and a brown fat cell. And they found that these beige fat cells were not in the typical location of the brown fat cells. The brown fat cells, like I said, the neck, around your spine and some of your vital organs, they found that the beige fat cells were actually in the same locations as the white fat cells, of course. And then, of course, as they did more research, they found that the beige fat cells were there. It was a white fat cell before, but then it started kind of turning into a brown fat cell in function, which means that it started to gain more mitochondria. It started to produce more energy and heat, but by nature and by structure, it actually is a white fat cell that starts to be beiged over, or it's called beiging, over. So, but the thing is, what's interesting is, here's the thing, is I will say yes, Lynn says, okay. So the thing is, you will actually never change the total number of brown fat cells in your body, okay? So I'm going to explain this because it seems confusing. You are genetically predetermined with a certain number of brown fat cells in your body due to your genetic coding, okay? You're not going to ever change the total number of brown fat cells. However, could you change a white fat cell's expression due to lifestyle factors like exercise, kind of what you eat, different things that you do? And they found that, of course, like I said, research is always coming along, right? But they did find that, yes, you could change the white fat cells gene expression, which would be called epigenetics, the expression of the gene, to be able to actually express itself more like a brown fat cell function, so that it can actually become more metabolically active versus just a dormant white fat cell. So this is really interesting because it means that you can kind of have a little bit more beige fat cells, not necessarily turn it to brown, but it can make the beige fat cells more metabolically active than just dormant fat cells, which is kind of cool, because then you would know that, hey, like at least I can kind of change my white fat cells into a little bit more metabolically active if I can do certain things, which are a lot of things that every health professional will tell you, a lot of the healthy habits and all of that, which we'll get to in a bit. Now, but I hope it makes sense though, because even though you have beige fat cells does not mean they're brown, right? Because brown fat cells is actually like structurally completely different, okay? But the beige fat cells are they function slightly differently. They produce energy and heat as much as a brown fat cell, but you know, like a brown fat cell it produces heat and energy by utilizing that protein UCP1. So it has a lot of mitochondria to use this protein to produce heat and energy in a brown fat cell. In a beige fat cell, it actually doesn't utilize UCP1. It doesn't actually have as many mitochondria as a brown fat cell. So if you want to like look at it in a spectrum, white fat cells would be one nucleus, one big fat lipid, and one mitochondria. Okay, let's just simplify this. A beige fat cell could be, you know, some fat lipids, maybe 2 mitochondria, maybe 3, and it's beigey. And then there's like brown fat cells, which is like 10 or 12 mitochondria, and then there's no big lipid drops, very small lipid drops, because it's not really dominated by lipids, it's really dominated by mitochondria. So this is why like beige is kind of right in the middle. It doesn't have as much mitochondria as brown fat cells. So it actually triggers heat and energy, not from the mitochondrial like utilization of UCP1. It generates heat and energy from a hormone called irisin, and this irisin hormone that gets, you know, secreted also produces heat and regulates like, you know, like the body temperature and everything. So it also like uses energy, but through a different function, right? So that's why it was kind of a tricky question I asked all of you. It was kind of interesting because I look back above, because it was a half and half. People were like, yes, you can turn it to brown fat. Some said no, and some said maybe. So I guess the answer is kind of like half. It will never turn to a brown fat cell. It'll become a beige fat cell. and so this is where that craze is coming along of like, you know, all of like this cold plunge and cold baths, and there's other things too. I know that with the cold baths, a lot of it, they're talking a little bit about like the adrenaline and some other hormones that it secretes when you get into a cold bath. But one of the things that are coming along with the cold is because they're talking a little bit about how it can activate better of your beiging process, which is turning white fat cells to possibly a beige type of gene expression.